Ferrari just launched their SF-25, and in this video we're going to go from the front to the back of the car, looking at all the interesting aerodynamic details on it. For those of you that are new to my channel, I was an aerodynamicist for Mercedes for the 2018, 19 and 20 Formula 1 seasons, and now I work as an aerodynamics consultant, designing race car aerodynamics kits for cars in all different classes all around the world. Now, like I mentioned on the McLaren video, with the launches this year in general, a lot of the cars are going to be evolutionary. We've seen a lot of the concepts of this rule set already being explored because it's the last year of the rules, and the Ferrari isn't too different in that regard. However, there are a lot of details all over this car that are actually quite interesting. This video comes with my standard disclaimer that no aerodynamicist can perfectly predict flows by eye. You really need CFD, track and wind tunnel data to be able to work that out. So everything I say in this video is at best an educated guess. Anyway, let's get to the analysis. So starting the front wing, we have a setup that looks like it's a carryover of what was run at some point last year. So you can see that on the left, I have the front wing that was run on the car last year. And on the right, I have one of the launch renders. You can see the curvature distribution along the trailing edge of the front wing is pretty similar. You can see it's got the same detached center section of the front wing, and it's got the same sort of detailing in this outboard portion around here. And in general, I've extensively covered the effects of varying these front wing curvatures and detaching the front wing elements in previous year's videos, so I'm not really going to go into that anymore. But one thing that is interesting that I will discuss about this front wing, because I didn't get to cover it last year because this spec was released halfway through the year, is the end plate detailing in this region here. Because while it's similar to some other detached front wing end plate setups that we've seen, there's some detailing around here that I think is quite neat to talk about. This is a shot of last year's front wing, and what you can see that we've got the two detached rear elements over here with stays at the back connecting them into the end plate. Now, I've previously discussed in my Mercedes video from a few years back how the rules allow you to detach these elements like this, but I think what's really interesting here with the approach that is being used here is that it's actually fully curled around. It actually comes back into this basically vortex generator type shape just through there. So we actually have two little upwashing veins here. Now, and below it, they've got a bit of downwash on these two elements down here. They're neutral to slight downwashing. So you can see that the lower portion of the wing is trying to go down. This upper portion here is trying to go up. So what you should get is some vortices that are spooling off this way. Now, we have to think a little bit more here because we have a scenario whereby there's comparatively high pressure on top of the wing to what's underneath the wing. So the pressure distribution may not be as it first seems, but with the presence of this end plate here, I would hazard a guess that this pressure here is high. And with that upwash on these tips here, my best guess would be that we are getting a vortex rolling in that direction off there. Now, when we look at this in the context of the wing, you can see that we have an upwashing section here, which is shedding off a vortex in this direction. We have the outer canard on the outer face, which is shedding a vortex in the other direction. And what's going to happen here is that you'll end up with an upwashing region in between these two vortices and a bit of a downwashing region a little bit further around here. Now, in terms of the specifics of what this is doing downstream, it's very hard to predict flows in this region, but given the location of this particular geometry, it's most likely that they are using that to manage some tire wake aspects. Potentially this vortex could be passing along the outside of the wheel. The high pressure in front of the wheel could be passing it to the outside, or the downwash from the front wheel may be pushing it down more towards the contact patch. Very hard to predict, but it's going to be something to do with dealing with that front face of the tire or the sidewall of the tire or the bottom of the tire down there. Going a bit further rearwards, we can discuss one of the more major changes mechanically on the car this year, which is going from a push rod in previous years to a pull rod this year here. Now, push rod and pull rod don't have, strictly speaking, an explicit aerodynamic benefit when it comes to car design. If we look back through these rule sets, we've had cars divided all over the place on this particular rule set, so there's clearly no magic bullet solution that's all required. And then if we look at the previous rule set, the one that I was working on, most of the cars there tended to have a pushrod suspension on the front end. It was pretty much ubiquitous. So there's not a strict reason why you need push rod or pull rod. However, when this change was discussed, and when several teams have talked about changing from push rod to pull rod, they've been talking about the aerodynamic effects of the change, not just the mechanical effects of the loads, the weight, the center of gravity, how it's all packaging, but the aerodynamic effects. So that means it bears some investigation as to why there would potentially be benefit in moving towards a pull rod setup. Now, there is one thing to be said for the fact that if Ferrari has been sticking with this push rod concept for several years now, they would have exhausted a lot of the development potential. They would have done a lot of the optimization around the scoop, around the cake tin face to try and get all that sort of optimization sorted. Now, there's a fixed wheel deflector along here, which they can't really play around with, but they can do some tweaks that they would have probably maximized at this point. Now, generally speaking, when you move to a new concept, you might take a small hit, depending on how well you did your first concept job. But if you take a small hit on the concept or even a neutral concept, and it opens up new doors for you by establishing a new flow field for further downstream, then it's generally something that you want to do because you need to keep pushing that development process along. And so even if this concept might have been a slight loss, and I'm not necessarily saying that it is the sort of thing where it would enable more potential for development as the car moves further along. Now, on top of that, let's talk about some potential reasons as to why it might be beneficial from an aerodynamic standpoint. And the main thing that comes to my mind is the interaction between this part of the rod here and the actual scoop just here. If we look at the push rod design from last year, what we can see is that it actually comes in and meets the scoop. And then it's worth noting that the push rod would usually go further out to the upright, more around this point here. So that push rod there has a relatively high amount of articulation that needs to be covered in this junction with the scoop. And also aerodynamically, it does cause some problems with where the scoop is. Because if you imagine if we looked from top view down, that we would have a scoop profile that's looking more or less like this, and we have our push rod coming in somewhere around here. And then what happens is that as the flow goes and blows along here and gets curved around here, we have a lot of loss off the push rod, a bit of junction loss in there, and this curvature is going to try and expand that, and that could cause problems for us further downstream, particularly when it comes to the wheel wake sitting just behind the front tire. Now, when we look at the new concept, we can see that this particular junction is raised to the top of the scoop. The scoop actually sits below the push rod. And that means that this face over here, the vertical face on the outboard side that's doing that curvature, would be clear of the push rod. And that potentially would clear up the trailing edge of that face. And maybe that helps with them managing the mid-wake because they can get a little bit more outwash from the rear of the scoop. That then helps them push the mid-wake out a little bit, and that might just be a better solution for them. And like I mentioned, if you can change the flow field off the front wheel and not really incur much aerodynamic penalty, it usually opens opportunities further downstream for re-optimization. This also frees up opportunities with respect to scoop location, where if the push rod is decoupled from the scoop and up there, we perhaps have a bit more freedom to play around with the vertical location of the scoop and the position of the scoop inlet with respect to the scoop trailing edge, and that will obviously affect the downwash profile across the scoop and also where the stagnation of the scoop is located. So all of those things can be played with to enhance the performance by either controlling where the bulk flow is moving off the front wing by changing the stagnation region, or by changing the downwash profile of the scoop, which can affect the performance of the lower deflector and potentially affect the lower wheel wake, or by just changing where the outwash effect of the scoop goes and hits the rear tire wake. So these are all things that they could be playing around with, and this could be why they've moved to a pull rod design. Now, on the inboard side, there's obviously some ramifications there. Perhaps it brings the bottom of the nose down a little bit. Whether or not that's a positive feature, it's quite unclear. But that might be something that they're playing around with down there. Although in fairness, if there was an opportunity to gain performance by adding volume here, they could have done that without moving to a pull rod suspension. So chances are it's mainly on the outboard side if I had to take my pick of where the aero benefits are. Going further rearwards, you can see that the Sidepod inlet geometry has changed quite a bit since last year. What we have on the New Year's car is that we have the inlet sitting a bit further rearwards, and I'll go to some front-on shots later so we can discuss the shape when viewed from the front. But it's sitting further rearwards than the previous car, where it had an upgrade pack that had this inlet quite far forwards. And last year's car also had the vertical section over in the forwardmost portion of the legality box coming there. The New Year's car has that vertical section much further rearwards, and that gives it a larger wing section that sits over the sidepod inlet, and also is just shifting all that sidepod inlet volume rearwards. Now, why would they be doing this particular action? Well, as we've always discussed, a lot of the management in this region comes down to how you're managing the pressure in this particular area, what you're doing with that with respect to the onset on the floor leading edge, and also the effects of bulk pressurization here on your ability to shift the wheel wake outwards. So moving this rearwards may give them a region that is captured by this larger wing that is allowing them to get more high pressure further down in this region, and potentially getting a little bit more powerful outwash in that region. It's very hard to tell at the point we're in because we're really moving between refinements here between the different cars. If we were to consider the difference between the car on the top and the car on the bottom, basically from a top-down view, if I took a slice through here, you would see that this car would have an inlet and an undercut that looks something like that. So the main chassis wall would be along here. Whereas the new car this year, if we had the same chassis wall along there, would be sitting much further rearwards, and then it would most likely kick out a little more harshly in terms of severity. So you can see that that would increase the pressure in here because we've got more curvature in that region there. But then depending on how well bounded that pressure is by the top wing, and obviously it's bounded well by the floor, that would change how the pressure propagates upstream, which would of course change how the wake is being shifted outwards. So very hard to predict the exact effects here, but that's more or less what's going on. If you take a look at the actual inlet shape here, you'll see that it's got this softer corner into a vertical portion instead of cutting across harshly like last year's car did. And this is kind of similar to what I was talking about on the McLaren video, in that they've obviously rounded this corner because they feel like they don't need to have this particular portion of the side pod pulled as tight in as possible. And it's worth noting that they actually, like the McLaren again, they have quite a large inlet in the vertical sense here. This is quite a decent amount of height compared to what we've been seeing on some cars. However, the Ferrari has actually moved laterally that way a little bit on its outboard edge compared to the previous year, and this gives you quite an interesting side pod inlet shape when you look from the top, where you can see that they have this particular portion of the side pod is actually coming out at a bit of an angle, and they cut back in and then outwash again. Now I wonder how much of this is trying to align this leading edge region here, because obviously you have air that's trying to come in at the front here. There's going to be a higher pressure on the front of the inlet. It's going to try and angle out. So you need to have the right acceptance here to keep that air nice and attached and clean. But then they're trying to create a good bit of high pressure here and outwash, so then kinking back out all the way to legality. So it's kind of got this weird double curvature, but you can sort of see why that could be beneficial. The other thing that's really interesting here is how they continued this curvature through here when they blend into the winglets. Now some of this might be how they have to deal with the legality and the radius, because obviously there's quite a lot of rules they have to satisfy here with respect to the sections and all that, but it does look somewhat intentional that there's a raised section here that's still outwashing. So that might just be getting that tiniest bit of extra outwash and pressure on top of the outboard portion of this upper winglet here. Speaking of that upper winglet, it's got a detail that I was discussing a bit in the McLaren video, but again, Ferrari has quite a different execution of this. The outer portion of the winglet comes along here and it curves up. Now, what it looks like here to me is that this portion of the winglet is either neutral or slightly inwashing. Again, though, like we were discussing in the McLaren video, we have a scenario where there's a high pressure down here, we have some upwash on here. There's probably going to be a degree of suction in here, but then how you control that, it depends on your mirror stay and how that's behaving there. And the mirror stay on this Ferrari is pretty interesting. We'll get to that in a second. But so we could potentially have this high pressure region bleeding around here to the outside, and this vertical uptick helps restore that. But by the same token, it's not as outwashing as we saw on the McLaren. Like I say, it looks almost inwashing. So I wonder if this is just them trying to back off the strength of the tip vortex that would potentially be rolling around that particular tip. Maybe they're just trying to move that vortex a little bit higher, weaken it a little bit. Or alternatively, I could have the pressure distribution incorrect here, and with that bit of inwash, maybe they are getting a relatively high pressure bit on the side pod there. However, the mirror does give us some clues that that might not be the case. And unlike most teams where we seem to be seeing this intent to downwash the mirror wake with a stay that goes over the top of the mirror, Ferrari's stay instead is going underneath the mirror. And let's have a look at another shot of that mirror stay. If we have a look at the Ferrari mirror, what we can see is something quite different to the usual downwashing approach that we see on these mirror wakes. You can actually see when you follow the camber of this mirror stay that it's clearly an upwashing element. We've got some degree of flow that's coming onto the mirror. The mirror's going to have some stagnation, some flow going underneath it, but the element that's the wing stay definitely looks like it's trying to support that mirror wake and push it upwards. Now, there's a few things going on here. One is that that stay with that camber will be locally making some degree of downforce, and that will also cause a suction region underneath the stay. That suction region will interact with the top of this outer portion here, and it will lower the pressure in that box that we identified earlier. So we're going to get lower pressure in this region here, and we'll get slightly higher pressure on the top, but doesn't really seem like that would be something that would be beneficial from a front wheel wake perspective. So what I would have to assume is that they are trying to deliberately upwash the mirror wake to keep it perhaps away from the sidepod, or maybe they're positioning this in a certain way with respect to the rear wing further downstream, and that must be of benefit to them. Maybe they've got excellent front wheel wake control, particularly with moving to the new front suspension that might have resulted in better front wheel wake outwash, and they don't need to use the mirror so heavily to control that front upper wake. So maybe they're just saying, okay, don't worry about the front upper wake, we've got that, it's good. Let's focus on managing the mirror wake to an area that we want it to be. And with the side pods that are being quite downwashing towards the rear, perhaps moving this mirror wake up and away from the downwash of the side pods means that we get the cleanest possible flow down towards the rear diffuser and the floor outboard edge, and that might be a beneficial thing in terms of overall performance. But this is certainly an interesting detail to see. The other interesting part of this equation is when we look at how the stay changes across its span. We have on the inboard side of the mirror, we've got a vertical portion of the stay that looks like it's outwashing. So again, trying to push this mirror wake up and out. And this is going to produce some degree of vorticity over the top, rotating this way. And it's going to produce suction on this side. And if we actually have a look at the profile of the mirror stay on that side and look at how it looks where it intersects with the vertical inboard-most portion of the stay, it looks to me like this whole section of the stay here, basically everything from that vertical portion inwards, might actually be downwashing. So maybe what they're trying to do is that they're using this portion of the stay as we would conventionally see, producing that extra high pressure in this region here to help with any sort of management of getting more outwash on that upper wake there. And then they're just focusing on taking that mirror wake by itself and pushing that up and out independently of what they're doing on the inboard side. That is potentially what is going on here. So it's a super interesting solution, and I think it's a pretty cool one to see. Looking a bit lower down at the Bargeboard, the curvature is nothing too crazy compared to what we've seen from their previous cars, but one little detail there is you can see it's got these little steps back there. This is not a detail that I would really expect to have a huge impact. I'd imagine this would have been a very, very small gain in the tunnel. But what these steps can do is that if you imagine you can have an edge like that, and you've got a pressure distribution along it, and you've got a pressure distribution on either side of it, and you're shedding off a vortex, is that each step will shed its own little vortex, and sometimes when these are separate and they combine further downstream, the end result can be a little bit cleaner than having just one big shedding edge going along there. But again, this is a pretty subtle detail in the scheme of things and is not anything too crazy. Moving a tiny bit further back and up, let's talk a bit about the halo detailing. Now this particular winglet that you see over here is from their previous year's car. So you can see the winglet itself hasn't changed too much. It's really very similar. But again, it's something that's quite interesting to discuss. And it's not the only detail going on the halo. Now, the halo is fundamentally a giant downwashing element. If you think about it, the trailing edge is lower than the leading edge, so the whole thing is angled down. So if you have flow coming on, it's trying to downwash it downwards, and what you'll end up happening from that is that you'll end up with some vorticity getting shed. You're going to end up with some degree of vorticity that's rotating this way, being shed off the outboard edge, And the inboard edge, which is also downwashing on this ledge, will end up with some vorticity being shed in the opposite direction. Now, because we have a large downwashing center section around the front, you would anticipate that the majority of the vortex strength would be concentrated in the outboard vortex more than the inboard vortex. Now, if you go through and add an element like this, which is applying outwash there, that's going to add vorticity in the same direction as the outboard edge. So what it's going to do is it's going to resist the formation of the vorticity on some of the outboard edge, and instead transfer that to the top edge of this vortex generator. In doing this, it will reposition the vorticity both of the inboard edge and this outboard edge vorticity. So you'll generally power up this outboard vortex, making that the stronger vortex of the two. You might suppress this inboard vortex a tiny bit, and you'll also be able to manipulate the position of everything by having an element that you can control the location of. So we're going to have our dominant vorticity coming along here, and then you can see that that's going to start to get housed by these fins further rearward. So that vorticity will be sitting in there, and then your inboard vorticity will be running along somewhere along there, a bit more further to the inboard side. You can imagine that we've got vorticity going the whole way along here. They then are going to try and position that in a manner that is beneficial for them further downstream. Now, on this particular shot, what you can see is the halo winglet itself has a flat portion with quite a lot of upwash. Now, on the McLaren video, we discussed the benefits of having a halo winglet with inwash and the fact that you can help control your cockpit loss better and you'll get a bit of vorticity off the top. But on this Ferrari setup, what you'll see is that we've got a shedding edge off here, so we've got vorticity that's going that way, so that vortex is spooling off that way downstream. We have a vortex going the other way off the top of the halo, and those two vortices can be used for controlling some of the flows along the body. So if we've got this vortex going this way, we'll have bulk flow rotation that way, obviously small vortex, not super powerful, but that could potentially help with flow attachment and flow quality as you move down this downwashing portion of the side pod further rearwards that goes into that big tub gully. By moving to having this as an upwashing element instead of just being flat or vertical, they're going to be able to power up this vorticity off here more than it would be otherwise, and also they're going to be able to locate that vorticity a little bit higher, which, if that's what they find is beneficial in the tunnel, is going to be what they're trying to do. Perhaps the reason to move that vorticity higher up might be to get it clear of what's relatively clean airflow going over the top of the side pod down here. So therefore that clean airflow gets fed down to the diffuser, and this vorticity might go a little bit higher to somewhere a little bit less critical when it becomes effectively lost further downstream. And of course, with these two vortices sitting here on either side of this curvature region, they've sort of got houses to go along in, and they would be energizing the boundary layer as you move further rearwards, which would of course improve its ability to resist separation. Not like the upper surfaces are being worked that hard, but certainly on the lower surfaces that could be a problem. So they're clearly investing a little bit of effort into this area to try and improve that flow quality to the rear. And really a lot of the developments we've seen over this rule set are unsurprisingly focused on improving that flow quality and onset to the rear diffuser region. Speaking of that region, we haven't seen anything too different on this car with respect to last year. We've got this cooling outlet on last year's car. That's very similar to the cooling outlet we've seen on this year's car. The floor edge wing along here looks pretty much the same. It's basically a slot to allow some fresh air through there, so some clean mass flow off the top of the floor, go in, shed some vorticity, let that vorticity move further inwards, and then go and enter the main tunnel. So it's nothing too crazy, and again, not really an update this year. Of course, it's worth noting there's clearly a few details around this rear stud, for example, that aren't quite visible on the floor currently. I'd say this is probably an appendage for fixing some test equipment like a rake or something like that, but there's every chance we will see floor changes, and of course all teams do tend to update their floors during the season, so no surprises there. Looking back at the beam wing and rear diffuser, again, we're not seeing anything that's too different to some stuff that we saw last year. We can see that they've given us this single beam wing configuration down the bottom with actually an upwashing smaller beam wing just above it. Last year, we ended up with that same sort of setup being shown at some places there. I've spoken at length in some of my other videos about how a single beam wing works and how it was actually a bit surprising for me in the first year when lots of people weren't rolling out with single beam wings. So feel free to go back and check my video library for more information on that particular detailing there. In addition to the same beam wing, you'll also note that we have this sort of stepped outer floor edge where the floor steps like that. And you'll see that that detail is similarly replicated on the new car. As far as I can tell, these are basically just trying to replicate the effects of the old diffuser winglets in the outboard corners by getting a little bit more outwash and upwash in this region here, while still respecting the radius and curvature requirements of the new legality of the rules. Looking a bit higher up though, there is some interesting detailing on the rear wing that I don't recall seeing last year, particularly around this centerline. What you'll note is the centerline has quite a lot of dip down and then a lot of curvature through it. It's very heavily being worked through the centerline here. And if you have a look, there's not a crazy amount of downwash on the rear bodywork either. The rear bodywork through the sort of cannon section is quite sort of longitudinally aligned. It's not downwashing like we've seen on some other cars. So perhaps this is a reflection of having some degree of support from the engine cover. It's not getting huge downwash, so then you can go and crank the center section of the wing quite hard, but then backing off the outboard section of the wing is going to be perhaps more efficient. It's again worth noting that cars run with many rear wings over the course of the season. This looks like this could be a medium low downforce rear wing. So this just might be the approach they're taking in terms of wing loading distribution. Now, the other thing too on that rear wing is that we're starting to see more and more aggressive cutouts here. Now, of course, with the new rules, they initially mandated these weird rolled over rear wing end plate tips, and teams obviously didn't like that because this corner here gives a lot of expansion that causes a lot of separation because you have a three-dimensional expansion right where you don't want it. And so a lot of teams have been progressively increasing their notches over the years, but this is getting more and more extreme, where basically these days we have a full square, full height element basically all the way to the notch, and then we just cut down and go straight along there. So there's basically no more three-dimensional expansion here, and it obviously allows the wing to get cranked very hard, get a vortex around the edge so that flow attachment is good and strong along there. And that seems to be a strategy that everyone is trending towards, but this is of course quite an extreme interpretation there. One of the details that may be feeding in to that rear wing design is this centerline Sharkfin venting. So if you have a look, you have in this center Sharkfin area that's sitting along just around here, you can see that the Sharkfin is broken up into a number of discrete vents in this region here. This would be providing a small amount of cooling, nothing too crazy, but of course there are items that need to be kept cool in this region that this could be a logical air exhaust spot for. So let's talk about the external aerodynamics of that. Now, obviously when you have crosswind, yaw, or anything like that, you're going to end up with some degree of vorticity getting spilt off this shark fin. Now, by stepping it with these cooling cutouts, what you're going to do is you're going to discretize that vorticity. You're going to split it up into smaller singular vortices instead of one big vortex. So each one of these little segments is going to shoot off its own little vortex. And as we talked about before, splitting off into smaller vortices can help with cleaning up the overall vortex flow. Now, there is the complication here in that the cooling flow that will be exiting these vents will be lower energy than the free stream flow. So this flow is going to get rolled up into some loss. Now, my assumption would be that all of these losses are going to go through and they're going to position them to pass basically in between the main rear wing and the beam wing box. So basically passes between and shoots out without drastically affecting either one too much. And I'm sure they've played around with the positioning of that to achieve that. And that's probably why it starts all the way back here instead of starting further forwards, say this region here. This may also be feeding in to that centerline loaded rear wing shape. It's hard to predict exactly how the losses are going to respond to the additional expansion of the centerline wing loading, but sometimes if your losses aren't overexpanding, which might not be the case because we obviously have a lot of high pressure down the bottom here, but the losses from that vent may in fact mean that the center of the wing is naturally less loaded and you could crank up that center to then recover some of that loading. Again, very speculative in this region, but that is potentially what could be happening. And that's my analysis of the SF-25. Well, that's all for this video. Thanks for watching. If you liked it, don't forget to hit that like button and subscribe to my channel for more content like this. Leave a comment below on what videos you'd like to see next from me, and hopefully, I'll see you next time.